All right, now today's objective is honestly just to practice the things that we've learned so far with piecewise functions. And then I believe there's a mini check that's around the corner. So this video is for those that would like to listen just a little bit more, perhaps to see and hear how we can evaluate a piecewise function, and then I am going to graph one more. So this is a practice paper, but I'm going to kind of go over two problems for those that would like this extra support. So evaluating. Remember, that means just plugging in. For this first problem, plugging in 7. Now, you're only ever going to plug in to one of the pieces. Which piece are we going to plug into? Well, it depends on what kind of number 7 is. Is 7 a number that's less than 4? I don't think so. Is 7 a number that's greater than 4? I believe so. So that means you're going to plug into this piece. You're going to plug in 7 right there, right beside 3, as you do 3 times 7 minus 5. So remember, when you evaluate a piecewise function, you only ever plug in to one of the pieces. And by the way, the answer is 16. Okay, there's nothing more to this problem. There's not a second answer. We just get 16. How about one more? If you plug in 4. Well, the first question is, what type of number is 4? Is 4 a number that's greater than 4? I don't think so. Is 4 a number that's less than or equal to 4? Well, it sure is. So that means I'm going to plug in to the x squared piece. And of course, the only thing that you're really going to do is square the number 4. That's pretty straightforward. That's just going to give you 16. Now, you might notice that you got the same answer for both of these. That's no big deal. It just means that they both produce the same y value. You try number 3. I'm going to skip down to number 7. What? I have no idea why the problem is numbered this way, but we'll call it number 7. But let's talk about graphing this piecewise function. Now remember, when you graph these, you first want to graph, or at least think about the graph of the entire line. The entire line that's represented by y equals x plus 5 would start at 5, and it would have a slope of 1. Now, a slope of 1 just means I'm going to go up 1 and over 1. Up 1 and over 1 in both directions if I choose, which I should choose because I always want to kind of see the entire line. Next, you're going to plug in the endpoint. You're going to plug in the x value of the endpoint. Now, when you do that, you end up with, negative 2 plus 5. And of course, that's going to come out to be 3. What we're really saying is that you have the point negative 2, 3. Now that point is right here, negative 2, 3, which actually becomes the point of focus for this problem. I want to label it. And now what I want to do is I want to use that endpoint or starting point, whichever you prefer, and think about the less side. The less side is the left side of that point. And the left side of that point would be the side that goes in this direction, which means that I really don't need the rest of these lightly sketched points so that I can have my my first piece of my graph. It's supposed to be an open circle, right? Because it's just a plain less than. I didn't have an equal sign. How about this equation? Y equals negative 2x minus 1. Well, you always want to think about the full equation. It's going to start at negative 1. It's going to have a slope that goes down 2 and over 1. You should go backwards a few steps as you think about the slope of negative 2. When you plug in the endpoint, be careful with your math here. That's negative 2 times negative 2 minus 1. Now, wait a minute. Negative 2 times negative 2 is 4, minus 1 is 3. Well, that ends up being the same endpoint. What that means is that I'm going to start where my other graph left off. I'm going to start right here at negative 2, 3. And lastly, I just need the side that's greater. The side that's greater would be the side that goes to the right. Now, when you go to the right of this point, you actually are going to be shading, or not shading, but you're going to be drawing the graph in this direction. And by the way, because it has an equal sign right here, I do want to equal, I want to fill in the hole. So I know it wasn't filled in to begin with, but it ends up being filled in to end with. You try the remaining problems on this little half-sheet practice as we keep working with piecewise functions.